For light, we see an object only if the light from it enters our eyes. So we see through our eyes only if the light reflects from an object. If light does not reflect from an object, we cannot see it. So this is very important point. So our eyes can see only if light reflects from an object and comes to our eyes. And when objects such as sun, electric lamps and candles make their own lights, so these are the light sources, we call them luminous sources. So sun, electric lamps, candles are luminous sources. Most things you see do not make their own lights but reflect it from a luminous source. So we see many of the objects that do not have any light source, but it reflects the light source, and we see these kind of object, and that object is called non-luminous object, such as this page and anybody, or the moon. Moon is also a non-luminous object because it does not have its own light, but it reflects the sunlight. So it glitters because of, or it shines because of sunlight. So luminous sources radiate lights when their atoms become excited as a result of receiving energy. In a light bulb, for example, the energy comes from electricity. In a light bulb, the energy comes from electricity. Excited atoms gives off their light haphazardly in a most luminous sources. So excited atom gives lights because of movement, haphazardly movement in a most luminous sources. The light source that works differently is the laser. Laser light is a light amplification by stimulated emission of radiation. Was invented in 1960s. In a laser light source, the excited atoms act together. They reinforce, they strengthen and emit a narrow, very bright beam of light. Say they accumulate and emits through a narrow beam, very bright beam of lights. So stimulated emission of radiation. So this is laser is a different type of source. Laser has a host of application. It is used in industry to cut through plate metals. For cutting of the plate metals, we use laser. Scanners to read barcodes at shop and library checkouts. CD players in optical fiber telecommunication systems. This is one of the laser application. And dedicated medical operations on the eye or inner ears use this laser. In printing and in surveying and range finding, lasers are used. So light travels. So these are the applications of laser, with very important. Industry for plate cut through the plate metal, scanners or barcodes, CD players, optical fiber telecommunication system, medical operations of eyes and inner ears, printing and surveying and range finding, some of the applications of lasers. Light travel in a straight line. Light always travels in a straight line. The beams are visible because dust particles in the air reflect lights into our eyes. So we see the lights, or we see the dust particles that becomes visible due to the reflection, and we see it through our eyes, these kind of dust particles, due to the light. The direction of the path in which light is traveling is called a ray. The direction in which the light travels is called a ray and is represented in a diagram by a straight line with an arrow on it. So light travels in a straight line and we see dust particles in the light straight line due to the reflection of light on these dust particles. A beam is a stream of light. It's a stream of light and is shown by a number of rays as in figure this. So here these are the parallel rays and this is the rays are diverging, expanding. Here the rays are converging at a point, diverging away from the points, expanding. So these are the beams of light. So parallel, diverging and converging beams of lights are there. And why and how shadows formed? Shadows are formed for two reasons. Because some objects which are said to be opaque do not allow light to pass through them. Secondly, light travels in straight line. So some of the object does not allow to pass through the light and the light travels in a straight line. So due to these two reasons, the shadows are formed. The sharpness of the shadow depends on the size of the light source. Suppose we have this kind of setup. Here we have a light source, we have a card, and on this card we have this small hole. Here from this light source will travel, and here we have a metal ball, and this light source will travel and we will see this shadow, a sharp shadow on this screen. So this is one of the sharp shadow we can see. In a second one, we have removed this card now from this setup, and we see this, that we have this dark shadow and a gray light shadow. So this forming a shadow like this one. This is a different type of shadow and this is a different one. Very small source of light called a point source gives a sharp shadow which is equally dark all over, like this. This is like a point source which gives a sharp shadow, while on the this may be shown in figure 3.27a, where the small hole in the card acts as a point source. Yes. If the card is removed from the lamp, act as a large or extended source as shown in figure 3.27b, like this. The shadow is then larger and has a central dark region, the umbra, surrounded by a ring of partial shadow, penumbra. So we have umbra and penumbra because of this. So here we have this kind of shadows. So due to this rays, we will have this penumbra. We can see by the ray that some lights reaches the penumbra but none reaches the umbra. Some of the lights reaches the penumbra but no one to the umbra. So this is the darkest region, and this is not because of this partial lights are reaching on this region. So that's why this is penumbra. Now the speed of light, the light travels very much faster than a sound is provided by a thunderstorm, because the flash of light is seen before the thunder is heard. So we see the flash first and hear the thunder later on. The length of the time lapse is greater the farther the observer is from the storm. The speed of light has a definite value. Light does not travel instantaneously. The light does not travel instantaneously from one point to another, but takes a certain very small time. Light speed is about 1 million times greater than that of sound. So light is 1 million times greater than the speed of sound. So the speed of light is very high. Reflection, mirror is used to change the direction in which the light is travel, is called reflection. Reflection, it changes the direction of the light in a regular fashion. So in a reflection of light, we use these terminologies. Normal, a line which is perpendicular to the surface is called normal. The angle between the incident rays and the normal of a surface is called angle of incidence. The angle between the reflected ray and the normal to the surface is called angle of reflection. So angle of incidence and angle of reflection are always equal. And the law of reflection is the angle of incidence is equals to the angle of reflection. So here we see this is the incident rays which is acting on this plane mirror. This area is polished, so on this, when this rays appear at this point, this is a normal which is a 90 degree from this surface or at right angle. This incident rays will be reflected. This R angle and I angle are always equal, and this incident rays will change its direction like this. The direction is changed, and the law of reflection states the angle of incidence is equals to the angle of reflection. The incident rays, the reflected rays, and the normal all lie on the same plane. So they are on the same plane. So the practical work, reflection by a plane mirror. Take care on a filament lamp and shielded will get hot when it is used. So this is a practical setup. You draw a line AOB. This is the mirror, and this is the single slits, and that can be moved, or this plane mirror can be moved, and this is a light source. So measure from this using a protractor mark angle on it, measure them from the perpendicular on ON. This is perpendicular on this, and what is at right angle to AOB surface. This is a surface AOB, and ON is a right angle to the AOB. Set up a plane mirror which is with its reflecting surface on AOB. So this ray of light is coming on this side. Shine a narrow ray of light along, say, 30 degree. Suppose this is 30 degree. If rays are coming on a 30 degree, it will be reflected on a 30 degree. The mirror, mark the position of the reflected ray, remove the mirror and measure the angle between the reflected ray and O, and that is the normal. Repeat for ray for other angles. So we will move the slits with different angles. So at 45 degrees, 60 degrees, 75 degrees, and we will observe this reflected rays. And in the experiment, what can you conclude about the incident and reflected rays? And the silver surface on the mirror is usually on a back surface of the glass. How might this affect the accuracy of your measurement? So this kind of experimental setup, we measure the laws of reflection or different type of angles, and this experimental setup is very important. In the next session, we will discuss periscope.